Hello and good morning, my dear students. Today I am going to discuss about the chapter 7, that is the equilibrium. Okay, it is another chapter of the chemical science or chemistry, you can say. Basically, what is equilibrium? So, equilibrium is a process or a state in which two opposite processes, that means the forward and backward reactions or stages or the processes occur simultaneously at the same rate. Okay, so the equilibrium is a step in which the two opposite processes occur simultaneously, okay, at the same rate. So then we can say it is a in equilibrium state. Generally, the equilibrium is exist in different stages of life also, okay, but this is another topic uh, different about the different psychological chapter. Okay, so I don't think this will discuss in this kind of lectures. Okay, so the equilibrium constant. Okay, so we'll discuss about the equilibrium constant. So what is equilibrium constant? So for a general reaction, when a mole of capital A and B mole of capital B, okay, reacts to form C mole of capital C and D mole of capital D as a product. Okay, so A and B are the here the reactants which are written in the capital letter, and the small letter are the number of moles they are using. So when these kind of reactions occurs and the equilibrium sign is given, that means the both forward and backward reaction are occurring in the same rate. So then the equilibrium constant is here that the capital C for its small c, that means the uh, the mole here act as a exponential form. Okay, so the moles are written in here as a exponential form. Okay, first we have to write as the product, then it's after that in the vinculum. Okay, after that in the lower stage we can write the reactant here. Okay, so this is the idea about the equilibrium constant, how it is written. So when we are going to discuss about the equilibrium constant at the partial pressure, then we can write also the partial pressure of C. Okay, and the coefficient are written as a power here. Okay, similarly into the partial pressure of D to the power capital small d, the partial pressure of A to the power of capital A, the partial pressure of B to the power of small b. Okay, so this is the idea about how the equilibrium constant is written. So after that the relation between Kp and Kc. Okay, so both are we can say both are in the constants. Okay, but there is a relation between equilibrium constant and the equilibrium constant at the partial pressure stage. Okay, so here Kp equal to Kc RT to the power del Ng. Okay, so what is that? So here R is the universal gas constant, T is the absolute temperature. Okay, and the N is now here the number of moles. Okay, okay, so G is here the your gas. Okay, so these are the basic things. So how we can predict the direction of a reaction? Okay, so when your QC is equals to Kc, the reaction of, we can say, the equilibrium stage. Okay, when the QC is greater than Kc, we can say the reaction is in the reverse direction. Okay, the reaction proceed in the reverse direction. When the QC is lesser than Kc, the reaction, you can say, the forward direction. Okay, so this is the idea. After that, the Ostwald dilution law, it is a very important for the class 12 students. So generally the degree of dissociation of a weak electrolytes that means alpha equal to square root of K by C. Okay, so this is a mathematical expression of the Ostwald dilution law. So here the mainly we have to calculate about the degree of dissociation of weak electrolyte. Okay, generally we are calculate the degree of dissociation of the weak electrolyte, not the strong electrolyte. After that, my dear friends, the ionic product of water. So what is the ionic product of water? So this is a general thing. Okay, so ionic product of water is 10 to the power minus 14 at 298 Kelvin. Okay, it is we have to remember the things. After that, my dear friend, Lee-Chatelier principle. What is the Lee-Chatelier principle? So when a system of equilibrium is subjected to a change of temperature, pressure, or concentration, the equilibrium shifts itself such a way that so as to undo or the counter out the effect of change. Okay, so the Lee-Chatelier principle explains that when there is a equilibrium state and when we are going to change about the different pressure, different temperature, then in order to make the equilibrium stage, the equilibrium shifts towards the different stages. We can say it can change to the reactant side, we can say it can change to the product side. Okay, in order to counteract the effect of change. Okay, so how it counteract, we have to discuss now. Okay, so the change of equilibrium. So generally when there is an increase in temperature, so what happens actually? So when there is an increase in temperature, the equilibrium shifts towards the endothermic direction. Okay, when the increase in temperature, the equilibrium shifts towards through endothermic equilibrium direction. Okay, after that when we are going to decrease the temperature, what will happen? So generally the equilibrium shifts towards the exothermic side. Okay, so after that when we are going to increase the pressure, so the when I am going to increase the pressure, the equilibrium shifts towards the lesser number of gaseous molecule. Okay, so when there is where there is a lesser number of gaseous molecule, the equilibrium shifts towards it. Okay, but when we are going to decrease the pressure, the equilibrium shifts towards to the greater number of gaseous molecule. Okay, after that when we increase the concentration of the reactant, the reaction occurs in the forward direction, and when we increase the concentration of the product, okay, the reaction occurs in the backward, that means the reverse direction. Okay, so this is a general idea about how the Lee-Chatelier principle helps to predict to predict about the shift of equilibrium. Okay, so after that the conjugate acid or base. Generally the conjugate acid, what is the conjugate acid? So my dear friends, when the H plus ion is generally known as your conjugate base. Okay, and when we are adding the H plus ion, we can say that it is the conjugate acid. Okay, so general idea this is. So after that the pH of a solution. So what is the pH of a solution? So pH of a solution is negative logarithm of hydrogen ion concentration. Okay, so generally the POH and pH is when it is we are adding it, it forms the 14 at 298 Kelvin. Okay, so after that, my dear friends, the common ion effect. What is the common ion effect? The depression of the ionization of weak electrolyte by the presence of the common ion from the strong electrolyte are called the common ion effect. Okay, so the depression of or the ionization of the weak electrolyte by the presence of this common ions forms the strong electrolyte called the common ion effect. Okay, so for example, when the degree of dissociation of ammonium hydroxide decreases in the presence of the strong electrolyte, that is the ammonium chloride. Okay, so the dissociation of ammonium hydroxide occurs, okay, or decreases in the presence of strong electrolyte, that is the ammonium chloride. So this is a general idea about the common ion. So this is the depression or the retardation of the ionization of the weak electrolyte by the presence of common ion from the strong electrolyte. So when there is a presence of strong electrolyte, its common ion having the weak electrolyte. Okay, so the ionization of weak electrolyte is reduces, it decreases. Okay, this is known as your common ion effect. Okay, so this is a general idea about common ion effect. So hope you will understand. Okay, so this is for today. We'll meet on the next video on some new chapters. Okay, till then keep watching and don't forget to subscribe. Okay, thank you.